Yeah. Això a vegades els posen verds i vermells, els daltònics no ens en entenem.
Jo som els punteros verds, els punteros davant eren vermells i ara són verds.
Sí.
Doncs quan vulguis.
Okay, thank you very much to everyone for being here this evening. And today we go on with the frontiers. So the point is that the European Academy has a hub here in Barcelona, and the hub is, we are working for that, Maite and myself, and one of the things we are doing is this kind of dialogues, and we do every month, one in English, one in Catalan or Spanish. Mainly one is more directed towards the state of the art in key questions, and the other one is more science for citizenship. So today we have this meeting again on the origins of language, and we will have today, as we try to have always, two different views on the same issue, and today you will see that the views on the origin of language may come from many different places. We have Tony Badia, that is going to be the chairperson of the meeting. Thank you very much to you, Tony, and to the speakers for having accepted to be here with us today.
Okay, thank you, Jaume. Language has always been seen as a distinctive feature of humans. Yet, the ephemeral character of linguistic acts and the extreme variety of human languages prevents very often to understand the core of the language faculty. In this context, one important question, not looking at the individual languages or at the individual linguistic acts, the question of what led the human species to develop the communication skill that language is, how did we acquire it, which are the driving principles of the development of language in humans. These are rightly appropriate questions which are hardly answered by standard linguistic research. They seem to require a much broader perspective. Actually, when Charles Darwin published The Origin of Species in the mid-19th century, a great interest in the origin and evolution of language arose, and lots of ideas and conjectures, without any empirical basis at the time, were presented. And this led the Société de Linguistique de Paris to impose a ban on all discussions on the topic. Too many speculative ideas and too little description of facts, testable hypotheses. Even so, in the last years, however, from the 19th onward, the topic has been retaken with a much broader perspective. The advances in the different linguistic approaches, quantitative, statistical, formal, computational, together with advances in biology and cognitive sciences, have led to a resurgence of the interest in the topic. So that today, the two extreme positions on language origin and evolution, which appear in the title of today's dialogue, language as tabula rasa and language determined by innate mechanisms seem too simplistic, and recent research, mainly interdisciplinary, sheds some new light in the topic so that we can rephrase them in a more nuanced way, probably. How much of the linguistic capacity can be explained by general, non-specialized cognitive and social mechanisms? How much of the linguistic capacity requires for it to be explained a specific cognitive device specialized in language? Consequently, the issue is discussed today from a variety of perspectives, bringing together many disciplines: linguistics with its different aims and approaches, biology and neurosciences, physics, mathematics and computer sciences, cognitive sciences, as well as archaeology and anthropology, and using a huge variety of research methods, going from formal theory to mathematical modeling or network analysis, I don't know. Hence, much of the current research, as a consequence of all this, much of the current research addresses the subject in a much less parochial way and using new tools to develop the topic. To introduce us to these new perspectives, we have two heavyweights in language research, specialized each on their own field, but trying to bridge linguistics to other disciplines in a quite strong way. The first speaker today is Cedric Works, and he's a research professor at ICREA, settled at the Universitat de Barcelona since 2009. He's the principal investigator of cognitive biology of language at Universitat de Barcelona. He was trained as a linguist in Leuven, Belgium. He moved to the USA to get an MA and a PhD in linguistics. After a few years in the USA, in USA's universities, he obtained his present position at ICREA in Barcelona. He's author of more than 20 books, hundreds of articles, book chapters, and conference proceedings. His current research can be said to be focused on the neurobiological foundations of human language faculty, with a special emphasis on evolutionary issues. He was trained in cognitive science and theoretical linguistics, but in his most recent research, he has moved to a more explicit biological and experimental orientation, which is going to give us one of these bridges I was talking about. His current projects are all intended to facilitate integration among disciplines and lead to a better experimental testing of theoretical hypotheses. So, Cedric, thank you very much.
Okay, thanks everyone. Thanks Jama for the invitation. Thanks Tony for the introduction. Thanks everyone for coming. I'm not supposed to move too much, which is difficult for me, but I'll be here. And I'll try to give you in a very small amount of time a few ideas, slogans that will be put on the table for discussion. So that's really my aim for today. I've put a picture of both Descartes and Locke to start off with, to just take as the beginning, basically the two extreme positions that are supposed to be what I get an echo. I'm just gonna wait. I think maybe the microphone is off.
It's good. It's off. It's off.
It's off. Okay. All right. Okay. Thanks. So I've put Descartes and Locke as basically the two representatives of the positions that I think no one really defends anymore, but they are still useful in informing the debate that hopefully we will have. So we have the empiricists and the rationalists on both extremes. And remarkably, I think the study of language directly informs a debate and has been doing so for like centuries. It's one of the few things that many disciplines can actually discuss. So if you think of philosophy, of linguistics, of psychology, and so on and so forth, they all go back one way or another to this debate regarding the origin of language. Let's see if this works. And I have a spoiler alert, right, that you basically need to be more or less in between those two extreme positions, right? The spoiler, I think, is not going to be a surprise. In fact, Lila Gleitman put it much better than me when she said that empiricism is innate, right? So you really need both positions, and the idea will be to try to figure out for which questions do you need more of one or the other, basically, right? And I think because of my past training, I'm supposed to represent the position that Chomsky is famous for. I was fortunate to be trained under him, and he's done more than others for the past, I think, 50 years to try to return to a position that he called Cartesian, because he insisted that you need some kind of innate basis to explain a very basic fact. Birds build nests, beavers build dams, and babies build grammars mentally, right? And this basic fact seems to him and to other linguists to require some sort of biological stimulus in order to account for the difference between us and our closest living and presumably extinct relatives that don't do so well on the language measures, as it were, right? That position is no longer as popular as it used to be. So this is the status of that position. It's the patient, right? And so we're going to examine the patient a little bit more and ask, why is it that this otherwise respectable and in fact dominant position in multiple fields has sort of died out, right? And I think in the interest of time, I'll summarize this in one picture. It's because when people asked, but what is it about our biology that makes us so good at learning a language, the answer that linguists like Chomsky gave is that, well, somehow the many things that we end up knowing about language is part of our genome, right? In some fashion. The key was the somehow, of course, right? And this idea is very reminiscent of how people thought at one point of the origin of organisms in terms of preformationism. Basically, they try to use a very easy answer. It's all packed at the beginning, and then over time it unfolds, as it were. This position becomes more and more untenable the more you learn about the underlying biology. Because the more you learn about the underlying biology, the more you see that this is not what you find. And likewise, if you think that part of language knowledge is part of our genomes, the more you learn about our genome and the more you find that there's no space for specific linguistic knowledge in there. So we're going to have to find some other way in defining what is innate about our predisposition to learn one or multiple languages, right? And I think that apart from this preformationist sin, if you want, that linguists made, there's another important dimension that linguists sort of swept under the rug for too long, which is the role of development. They basically decided that, all right, we know what adult language looks like. We're going to try to claim that right from the beginning, there is a lot of linguistic knowledge packed into the organism. And basically, between those two positions, development is irrelevant. When you learn a language, almost the way you set up the settings in your iPhone, you choose on, off, in any order you want. The end result is you speak English, Catalan, Chinese, whichever language you end up speaking. So they consciously pretended that development didn't play a big role in language learning, right? So you can see very often statements saying that, well, learning a language is so fast, right? And it's true that it's fast, but in some respect it's also quite slow. And this is one aspect that I want to stress, that the role of development is really very important. That is, yes, you have the beginning point, you have the end point, but you have all the intermediate stages that are worth studying. And I think linguists haven't done this so well. Right. To illustrate this point, compare these two paintings. Not going to tell you which one I prefer, but the one on the left, if I ask you to pick the point where you would start to redraw the painting, you'd be able to pick many different points and still redo the painting no matter what. Whereas the painting on the right seems to have a certain developmental order. In order to reproduce what you see, you need to really decide from which point you're going to start reproducing the painting. And the position that linguists often took is sort of the one on the left. It doesn't matter where you start because the end point is the same, right? Whereas the position that I think we should favor is one that really does justice to the many stages in language development, right? Here is another thing that I think is very important in the case of innateness debates surrounding language. Very often people have thought that what has to be encoded as part of our biology is the language facts that linguists are interested in, right? Whereas I think this statement often confuses what I like to call the building and the scaffolding in order to erect the building. I think what's important about our biology is perhaps not so much that it provides the building as such, but rather the scaffolding that enables you to build the building over time, right? And of course, people tend to be attracted more by the building than the scaffolding, right? But focusing on the scaffolding has several advantages. For one thing, for many different buildings, you can use the very same scaffolding. That is, the principles of scaffolding tend not to be as domain specific as the building themselves, right? And so perhaps in order to explain language development, if you focus on the scaffolding that's provided by your biology, maybe the scaffolding itself is not specific to language, but consists of generic biases that other aspects of cognition also feed upon. And I think that this could be a way of giving a role to biology without returning to the pre-formationist position of 70 years or 80 years ago. And there is really a lot of room in between the initial point of, say, birth or conception and the end point of knowing a language or several languages. This is basically a sketch of the many stages in the course of development between, well, actually before birth until puberty, which we know is very important for language development, because there's lots of observations that point to puberty being more or less like the end point by which you actually end up learning your first language or several first languages if you're multilingual. Right? But these many stages are all important in providing a certain scaffolding for language, and I'll try to illustrate this in a couple of ways. One of the things that happens during those stages is that you do interact a lot with peers, with parents, and that interaction, that social interaction, is absolutely critical in triggering your biology and feeding the predisposition you might have for language. And I think this has been a blind spot for the Cartesian position, that very often they've just focused on the individual as such. You know, a child learning a language sort of in isolation, right? Whereas I think a lot of the action, critical action, takes place in interaction. That is, as peers interact and develop their own languages. But we know that for that interaction to happen, in fact, for all of us to be in this room and you sitting quietly, we need a certain biology to be as patient as you are right now with me. Not all animals are as patient as we are in a closed space, right? That requires a certain amount of brain space in order to handle. So there's a long tradition starting with Dunbar saying that in order for you to have interaction with so many people over time, for example, like us, in order for us to interact in a big group, you need a particularly big brain, for example. Without that, you can't handle all the social relationships that are extremely important for you to develop a language. So even if you say that language development requires a social aspect, social interaction, that too requires a certain biology, right? This is a point where both interact. Without a certain brain capable of handling so many social interactions as we have, the cultural aspect, the social aspects of language would not be tenable, as it were, right? So that's one thing. The other thing that I think is very important is to realize that we are already too old to learn a language really well. We learn a language best when we are children, as I said before, puberty. That, I think, is a central biological fact. The fact that childhood gives us an advantage for learning language is something that biologists should really try to explain. Why is it that when we are an adult, in fact, when we know far more than when we are children, it's not as easy to acquire language? In fact, I'll put the paradox in the sharpest possible light. Adult linguists, experts in language, are worse at learning languages than children are, even if they know language as their job, as it were, right? But we fail in a situation where children do extremely well, right? What is it about childhood that makes this possible, right? And I think there is an answer that's emerging from many different fields, actually, that's well worth exploring. This is an idea that goes back to the notion of a critical period for language development that was first stated by Lennerberg, but it's been taken on by mostly psychologists and neuroscientists, seeing things that children do that adults no longer do. And one of the big differences is that children tend to explore the environment much more than they exploit the environment. Adults, there's basically a tug of war between two tendencies. One is exploration and the other one is exploitation, right? And it turns out that children explore much more. Adolescence starts exploiting their knowledge, and adults too, right? That exploration is critical, I think, to understand early language development. This bigger tendency to be willing to explore, to be willing to trust in the context of uncertainty is, I think, a situation, a condition that requires a biological answer that I think could tell us how we could actually provide this scaffolding for language learning. That is, we must absolutely pay attention to things that children do better. And it turns out that in some contexts, and language is one such, knowing less is actually knowing more, right? And this is an aspect that biologists, linguists, cognitive scientists, neuroscientists, all of these experts could actually study in order to understand why it is that there is a sweet spot in the course of development that makes language learning particularly effortless, much more so than when we try to acquire language, right? So let's skip this, and I'll end with a couple of thoughts. One is the interest on large language models recently and artificial intelligence. As impressive as they are, there's one big difference between them, their success, and children, is that they require far more input to work than children. This is basically a graph that shows you the amount of data that you need for large language models to succeed in some tasks, right? That's the top line. I don't have the pointer working. Whereas the maximum amount of data that children receive and exploit in order to learn a language are the lines below, right? And there's like at least 1 or 2 degrees of magnitude difference between the two. And until we figure out how to reduce the dependence of so much data on language learning models, we may not be able to figure out what it is that what it is that makes children so good at learning a language, much better than tools that require so much data. That's one point that I wanted to make. The other point I wanted to make is related to AI, but rather it's this non-human primate that some of you may know called AI as well. Trained in Kyoto since the 70s, extremely brilliant, lots of videos that you can find on YouTube, where that closely related species managed to demonstrate that many of the things that we thought were human exclusive, human specific, were not. In particular, lots of memory tasks where they do much better. Very often, this case is presented as basically a reduction of the differences between humans and other species, but with 2 critical facts that I think shouldn't be ignored and that go back to our biology. One of them is that this individual, I, was extremely good, but much better than her conspecifics. And she distinguished herself in 2 ways that I think are telling us something about how children learn a language. One of them is that she was extremely patient. That is, her conspecifics, after trying, for example, a task and failing, they destroyed basically the task setup, right? That prevented them from trying again, right? She rarely destroyed the setup, and as a result managed to accumulate knowledge in a way that was reminiscent of children. So being extremely patient as a learner, being less aggressive as a learner, is an important fact about our predisposition to learn things in a cumulative fashion. The other thing is that she was a female, not a male. She was also far less aggressive and more trustworthy towards the experimenters. And this difference of reduced aggression is also something that characterized childhood. So it turns out that, I think as Darwin said, if you want to understand many things about what makes us human, maybe you should read less of Locke and pay more attention to baboons. I think we should take that statement very seriously and try to appreciate that the biology that we may need to understand something as specific as human language learning may be rooted in biology that's actually shared across cognitive domains, but also possibly across species. The last point. So I hope everyone here sees a triangle in here. There is absolutely no triangle drawn. It's simply the result of your visual system making that triangle emerge, just because of the configuration of the dark figures, as it were. Chomsky and other linguists would say that the triangle is innate and built into our genomes, but maybe it's the dark scaffolding around it that makes language possible. And on this note, I will end. Thanks for your attention.
Thank you, Cedric. Our next speaker is Ramon Ferrer Cancho. He's a tenured associate professor at the Department of Computer Science at the Universitat Politècnica de Catalunya. He's coordinator of the new Quantitative Mathematical and Computational Linguistics Research Group of the UPC and head of the Complexity and Quantitative Linguistics Lab. After graduating in computer science, he obtained a master's degree in applied physics and a PhD in computer science with a thesis on language, universals, principles, and origin. He's an information scientist or a quantitative linguist with extremely broad interests spanning two other disciplines. Within linguistics, he has worked on the formal constraints on syntactic dependency structures, language universals, language variation, language learning, and language evolution. He has been opening quantitative linguistics to other areas such as biology and physics. Thank you, Ramon.
You're welcome. Thanks for the introduction. Okay. So what is the pointer is here. So Cedric started with this, let's say, opposite view from Locke to Descartes, from tabula rasa to biological determinism. Okay. So suggesting that perhaps there is a continuum or an intermediate solution. Okay. But I would like to add another dimension, that is mathematical truth. Okay, I think another dimension in a strong sense, as a complement. Strong complement. I have to warn you that my talk is going to be rather simplistic because I'm going to rely on just 4 components. One is mathematical truth, the other are statistical facts about languages, predictions we can make out of those mathematical truths, and then grounding. What is the grounding of the assumptions behind those mathematical arguments? And I would like to start with clarifying what I mean by mathematical truth. Let's take Pythagorean theorem. All of us know about it from the school times. There's a theorem that tells us the relationship between the length of the sides of a right triangle. And now let's reflect about what it means to have a mathematical truth. If I show you this right rectangle, you would say, oh yeah, it holds the theorem. Then I replace it by wood, yeah. I replace it by flesh, yes. So it's tempting to believe, hey, it's a matter Pythagorean holds because it's a property of the matter making it. It's because of the atoms or some physical reality. Okay, but indeed we can run a mental experiment. Let's go to the outer space in the vacuum, and there locate 3 points in the corners of the right rectangle. And still, in that vacuum, the theorem holds. Okay, so we think about the notion of determinism. We could say that okay, clearly there's a notion of biological determinism, things that are determined materially in our codes, in our genetic codes, but also a notion of mathematical determinism, namely some determinism stemming from some immaterial truth. Okay, but do we have in the domain of language something that resembles that? Let me consider the simplest, but one of the strongest examples. Let's consider a communication system that has to minimize the cost by reducing the length of the words as much as possible. So we can compute an average word length, okay? And then we ask extended information theory, what can you predict about such a system if it's coding meanings or words into strings optimally, okay? There's a general coding theorem that predicts that the correlation between the probability and the length cannot be positive. So in general, it would be negative, okay, or perhaps 0. So the correlation has to be negative in general. And this is just an extension of results from Shannon making very specific assumptions, okay? But now, that's a strong result. It's a theorem, okay? But reality is messy, it's complex. Will we find it in languages, okay? On the left, you have the relationship between length of a word and its frequency in English and Estonian, but you can see there is a decreasing trend. More frequent words tend to be shorter, okay? But is it a theorem of a strength equivalent to the Pythagorean theorem? Okay, Chris and I take a sample of languages, 1,000 languages, implying 30% of word diversity. Compared to the standard research in linguistics, it's a lot, language research in general. We get that in all the 800 languages, in all of them, we get a negative correlation, okay? And interestingly, it's independent. I mean, the appearance of that law of abbreviation, this tendency of more frequent words to be shorter, it appears independently of the writing system, independently of the linguistic family, independently of modality, whether it's a spoken or sign, independently of the unit of measurement. We are measuring in characters, in syllables, in strokes, in duration, in time, okay? So that is suggesting that is something, perhaps immaterial, manifesting in languages. Okay, but then, oh, Ramon, then all languages should be in that way, or even if we take other species, we should always find that. But it's not that easy, it's tricky. And then we go to other species, and we see a growing number of species satisfying the predictions of that optimal coding theorem, but not all of them, and the exceptions are very interesting, but I don't have time for that. But the point is that we could extend or then more general, this notion of mathematical determinism, transform it into one that is still mathematical but probabilistic. Things that are going to happen with high probability in a communication system that is being optimized to reduce the cost of communication, okay? But now I think that some linguists now are being bored. Oh, come on, you are speaking about word lengths and little words, okay, but what really matters to me as a theoretical linguist is grammar. Something related to the faculty of language, to the core of the faculty of language. And then what is grammar? Wow, man. Okay, let me say a few words, perhaps simplifying. Said, oh, it's a model, a set of rules of the sentences a speaker can produce. And we can illustrate that aspect of grammar through an acceptability game, where we say, okay, this is the grammar. I supply a sentence, and the grammar has to tell me yes or no, okay? So the 3 black horses, grammar says yes. Black horses 3 there, no. Well, I'm not a native, sorry. Okay, music love I, grammar says no. I love music, yes. Okay, but grammar is more. It's not only about telling you which sentences are possible, but also what is their structure. And the mainstream approach, the one that has been dominating theoretical debate, is the constituency approach. So I have a sentence, Anna hit the ball, and then in essence, the structure is just combining, grouping elements, forming higher groups. So from the ball, I get a noun phrase, and then I combine with a verb to form a verb phrase, and then I get to the whole sentence. This is the standard framework of phrase structure grammar, from which there have been very sophisticated developments such as generative grammar culminating with universal grammar. Okay? But that's not the only approach. Here we are meeting because Academia Europea is calling us. And we have to also think of alternatives coming from Europe. And an alternative representation is a dependency. We owe it mostly to Lucien Tesnier. And in that view, the structure is very simple. The structure of a sentence is just arcs connecting words, one word with another. The word that has the origin of the arc is the head, and the receiver is the dependent. So hit is a head of Anna, and hit is in turn is also a head of ball. Okay, and interestingly, this is the de facto standard in computational and quantitative linguistics. And you may ask, okay, why is there such a disagreement with this mainstream theoretical debate on what is the structure? Okay, I think computational linguists are very practical, and I think they apply a principle that people in this house know, utile non subtile legit. Okay, sometimes it's better to choose the useful, not perhaps the more sophisticated one. But then I think there's a very important point here, that is the cognitive realism. Okay, there are very beautiful arguments that can be made about the realism of that approach. Things that we can check and when we look at how the brain works. But I don't have the time for that. But I have to warn you that in the following examples, I'm going to assume that framework for the structure of a sentence. Now, let's play the game of acceptability test and consider that I'm going to supply two sentences, and now I have to use you as subjects, and I give you two sentences that are synonymous. John gave the painting that Mary hated to Bill, and the other sentence is John gave Bill the painting that Mary hated. Okay, and now, in addition to tell me, okay, this is acceptable or not, the point now is I want to tell you which of the two is more acceptable. And I have run the experiments many times, so we don't have the time to do it like that. But the overwhelming majority of people say it's the second. Yeah, in the sense it's easier when it's easier, when you read it and you understand it. Okay, and this is related actually to a principle that was put forward by a professor in my department, Glyn Morrill, who actually analyzed the syntactic structure of the sentence through the lens of dependency grammar. And on top of it, okay, what we are doing here in this slide is we are putting the distance between the syntactically related elements. So John and Gabe are at distance 1, so we are putting a 1. Gabe and painting are at distance 2, so I'm putting a 2 on top of the arc because there is an intermediate word, okay? And then I can take every sentence and count the sum of dependency distances, and what I see, what we find here, is that the sentence that is the easiest, the most acceptable, is the one that is giving us the lowest sum. Okay, so why is this happening? Well, because there is a general principle in a sentence that is the need to minimize the distance between syntactically related words. It's the so-called dependency distance minimization principle. Principle I put forward a long time ago, okay? And in terms of grounding, it can be explained by the fact that in our memory we suffer decay. As we move across the sentence, we are going to forget information, and in between a long distance relationship, there is going to be there's likely to be interference, okay? Now concerning, okay, let's move to the Pythagorean setting. How many languages have been shown to obey that principle, in the sense we can compare the actual distance with respect to a baseline, okay? And actually, we find in the latest study, okay, that if we take a particular collection, we find no exception, in 93 languages from 19 families, okay? So now, what is the conclusion of that analysis, okay? That there is a general principle, cognitive principle, that is dependency distance minimization, that sheds light on what happens in acceptability. Okay, but then I would like to move to other things that look perhaps separated from cognitive principles related to minimizing some cost under memory constraints. Let's consider the case of projectivity, which is a characteristic of sentences that Hayes and Deserve discovered in the 1960s just by playing with sentences, writing sentences, analyzing the structure. What is this property telling us? How is it defined? Well, it's defined by combining two conditions. One, that when you draw the arcs, there are not going to be crossings. On C, there aren't crossings, but on A, there are. So that the example above wouldn't be projective. And a second condition, that there is no arc that flies over the root node. The root node is a node that sends links to other words, but it doesn't receive links. Okay, is it grammar? Okay. Well, some linguists say, okay, there has to be a ban of crossings in grammars, but why? Okay. Others say, oh, let's postulate a principle of minimization of crossings. Okay. But actually, it can be shown that that scarcity of crossings results from actually the principle of dependency distance minimization. It's actually an epiphenomenon of such a cognitive principle. And to illustrate it intuitively, let's consider the sentence on the left, okay, where the distance is between nodes is very small and there are no crossings, okay? But now let's introduce disorder in the sentence by swapping at random a pair, swapping the positions of two words at random. And gradually, what we see is that the distances increase, but also the number of crosses increase, and we end up in a configuration of the sort of the right when we have many crossings and very long dependencies, okay? But you can also look, get some intuition of how the argument works by another experiment. We generate artificially syntactic dependency structures, namely those fancy trees with their positions, and then we select those that satisfy projectivity and compare the distances against a baseline. The baseline is, okay, I don't select any formal constraint. Let's take whatever, okay? So then this is the dashed line on B, okay? But then we select projectivity, we see a drop, okay? So it's, the conclusion is within those formal constraints, there's encoded, not on purpose, memory limitations of the human brain. And the full argument that can be built consists of a null model that predicts the number of crossing dependencies in both real and artificial sentences with an error that is smaller than 5%. Okay, why is that property so important? Because it's closely related to the notion of computational complexity. What is going to be the computational cost of solving the acceptability problem? I give you a sentence and you have to tell me whether it is valid or not, okay? And this takes us to Chomsky's hierarchy, who from a formalist standpoint classify languages according to their complexity, the simplest, the regular, then the context-free that contain them, then the context-sensitive, okay? And Arvind Joshi and others have argued that real languages fall in an area that comprises the context-free languages and a bit of the context-sensitive ones, and that class is called mildly context-sensitive grammars. And the funny thing is that actually that class that is defined under the framework of phrase structure grammar is closely related to the mild non-projective syntactic dependency structures as was presented before as a formal constraint. So actually, the very limitations of the human brain takes us to the complexity, computational complexity of languages. Okay, but dependency distance minimization is not just the only principle of word order at work. There is another need that is reducing the surprisal of the elements that are arriving. Okay, and to simplify matters, let's consider that there are two kinds of elements whose surprisal I want to minimize. I want to ease their processing. Consider that I want to minimize the processing of the head. So we have to choose when to put the head. I should put it as later as possible, namely as in the right bottom corner, okay? But if I want to minimize the surprisal of the dependence, I should put the head first so that I can help in their processing, okay? But the funny thing is that we have that the optimal configuration in terms of minimizing surprisal is putting the head at the ends. But then if we look at distances, okay, if we put the verb the head at the end, then we are getting a total sum of 6. But if I put it in the middle, I'm minimizing the length of the dependencies because I'm getting a total of 4, okay, if I sum the distances of the arcs. So there is actually a conflict between word order constraints. And now, as a scientist with some mindset from physics, I would like to catch when sentences manifest just surprise and minimization because both are competing. Okay? And then the prediction is, okay, surprise and minimization is more likely to surpass dependency distance minimization in two conditions, short sequences and when words are shorter. And let me take a very concrete example. Let's consider what would be the optimal placement of a noun in a quadruple formed by a determiner, a numeral, an adjective, and a noun. Okay? It's within the setting of having small sentences and short words. How do you know the words are going to be short? Because the optimal coding theorem tells us, hey, highly frequent elements are going to be shorter. This is the case of determiners and numerals of low number. Yeah? Okay, and the funny thing is that then we go to reality, we take languages and their preferences, and we find it in a sample of more than 500 languages. 64 prefer to put it in the extreme positions, either first or last. Now, let me close. I think perhaps I'm running too much, I don't know. But to conclude, what is my argument? Let's come back to the issue of tabula rasa versus biological determinism in one dimension. I told you I want to add another component that is mathematical truth. What is my argument? That what we observe in languages doesn't need to be triggered, okay, as a causal mechanism from the genes. I mean, it could be that, there is a mathematical determinism in communication in a system under cost minimization. Let me put it more clearly so that you have fuel for discussion later. My argument is that languages materialize incarnate mathematical truth or relaxed versions, relaxed probabilistic versions. And the mechanisms are open. It could be either biological evolution or cultural evolution, but be careful. Biological evolution is slow, and cultural evolution can drive changes much faster. Okay? Now, concerning the debate versus innate or learn, okay? What is my proposal? What does it mean, my proposal of an extra dimension? Okay? In a way, Ramon, you're presenting a Pythagorean theorem or the equivalent for languages. It looks like innate. It's not the same thing. And it means at some point during evolution, something in material form leads to an innate behavior. It could be language, it could be whatever. It could be a nest building. Okay, but the mathematical truth is something eternal. It doesn't have an end. It's always there. And languages and argument systems catch it. Okay? Now, but then, Ramon, is that reality a sort of environment? So languages evolve over those mathematical realities. So it's, in a way, you're making the case for a tabula rasa, in a way. Not exactly that, because, I mean, there's a subjacent reality. It's not that by interacting with my environment and sensory experiences, I get there, okay? So it's another dimension. Of course, I'm not solving the problems, but I wanted to call the attention on the fact that just by focusing on what a system in general has to solve, that is a problem of communicating efficiently, the many things that you can predict. So you don't need to encode them in grammar. So I'm now about to finish. I think we have, but I would like to challenge you by the fact that, okay, if we consider other species, okay, maybe other species have a brain that is complex enough to be ready to catch these mathematical realities, okay? But maybe you simply don't know, okay? And that's all. Thank you for your attention. And now I hope we can have a nice debate.
Okay.
So we should, yeah.
Cedric, would you make a short comment on Ramon's presentation, or shall we?
It's a bit difficult because we belong to the world evolution of language community. So in a way,
I can make one little comment actually, or since the slide is still there, I think it would be interesting to see, given that the linguistic systems that humans have is quite different from what you see in other species. If the brains of these species can actually latch on the same mathematical truth that you were alluding to, where does the difference come from? That is, what makes the human communication system so different from what we see in other species, if they have access to the same truth, as it were?
Yeah. I mean, the kind of question I'm making, that there is a lot that once you have a certain setting, you can predict about the system. Now the point is, what are the precursors? I mean, how complex the brain needs to be, how good at processing sequential information, no matter of the nature. It may linguistically be just sensing the environment, okay? And the same on, well, I like your point on culture. I mean, because I think we seem to perhaps think that there has to be something magic, and we are not aware of how much we have by cumulative culture. I can say, okay, I'm a university professor, but if I have to fix something at home, I cannot do it. I mean, there's a specialist who has this knowledge and knows how to do it, and this is the result of cumulative iteration. Yeah, and perhaps language is not as important as we think. As humans, we tend to think, oh yeah, this is a unique feature of us. But is it obvious that it's unique to us? I mean, there are obvious things. Chimps don't send rockets to the moon, for sure. Or other species, well, you would say, do other species have, or organisms have writing systems? You would say, obviously not, but if you think of bacteria have been changing plasmids, but in a sort of, in abstract way, a sort of written document. It's a molecular information that's being passed, okay? But I'm speaking too much, and perhaps it's time to come back to the original point. But I think what Cedric was saying in his talk is, in essence, the part that is missing in mind. I mean, okay, there is a mathematical reality that languages and communications can catch, but what about the timing? I mean, is it available at a certain age? So all what you were saying, I think it's relevant, very relevant.
Yeah, John. Thank you very much for the exciting talks, guys. I would like to go to what Cedric called the scaffold. So is this a way of changing a little bit Chomsky's view on the hardware that is not a real hardware? But at the very end, this scaffold, what it is, it's a set of neurons, it's a set of genes, it's a set of cells, or is not biological.
Okay.
And so the same or different question would be for Ramon, in the sense that if there is a scaffold in the brains that can catch this mathematical truth, this sounds to me as something similar to God, this mathematical truth you are talking. If you cannot make a difference between the human brain catching it and other species' brain, maybe the model is not that complete as it should.
Okay.
Cedric?
Okay, I'll try to be brief in the interest of other questions. So I think, yes, the putting the emphasis on the scaffold is a way to avoid, I think, the trap of asking too much of our biology, be it genes, being brains, meaning too many domain-specific details being built in. That I think the biology won't give you. What I think biology could give you, and here I think the options you are giving, genes, neurons, brains, they're all different levels working together, would be essentially learning biases, learning predispositions that help you construct the grammatical system that you end up having as an adult. So the rules, the predispositions, the tendencies of what you learn, what you pay attention to, what you find rewarding for yourself, right? These, I bet, won't be very specific to language. They are basically put to use in other cognitive domains, and many of them would be present, perhaps in isolation in other species, not as a collection. I think what makes us special is that we have a remarkable backpack of such learning biases and predispositions. That's why we are, as it were, different. But in and of themselves, individually, presumably you would find them elsewhere in other species. And so the role of the biologist would be to study other species and find these in isolation. That would be the short answer to a complex question.
Ramon?
And then, so I would like to follow your last point. I mean, you say, okay, if we are so unique as humans, I mean, in a way, your theory doesn't match with reality. I mean, your theory would predict that we would be more languages, more animal communication systems achieving a level of complexity that we would consider close to our species, right? But then my point, Jaume, is how can we be certain that another species doesn't have something of, I would say, equivalent complexity or something that is as a proto-language stage, as a certain language would put it. I mean, something that corresponds to the competence of a kid at 3 or 4 years, which is a simplification. But, Jaume, we don't have a test, I mean, in a statistical sense, with the tools of statistics, of data science or whatever, that can tell us whether another species is getting there. Such a test doesn't exist. So when we say we are unique, I think we are not being fair, okay? And my argument is, I think we are undervaluing the possibility that other species get there, essentially because we don't know. I mean, if I give you dolphin vocalizations, which ones? Whistles, well, that is a catch, okay? But clicks, we don't know. Some are for echolocating, some of them might be used for communication, no way of segmenting them. So it's very difficult to start from there, okay? But at the same time, dolphins exhibit many things that suggest that there is powerful communication behind in terms of synchronized behavior, for instance, the same for whales. And then I don't mean I have a complete argument for many reasons. One is because I'm focusing on economy. There's certainly there are other things. I'm choosing economy because something that helps me to work with the tools of science I'm used to work, to make solid arguments. There are other things that are relevant, but are not in my competence. And then I don't have a complete argument. I'm telling you, hey, I can tell you something about acceptability games. Yeah, I can tell you a lot, including principles that I haven't mentioned. But there is something that we haven't solved, even in language. what is the structure of the sentences? Oh, you ask a theoretical linguist, would probably, depending on the university, he might be more inclined to, let's say, adopt a phrase structure-like approach or dependency grammar, okay? But we haven't put the two together fairly, assessing, okay, which one is more real, more well-grounded by our brain. There is very little on this. So if we know so little about it, then can we delimit clearly our species from others that also have complex brains and exhibit complex behavior, communicative behavior? So that's my point.
Let's move to another question, Genoveva.
Yeah, I'm just curious about two things. What do you think is the status and the force of this argument that some linguists think that is rather crucial, or used to think that is rather crucial, and it's this idea that even when you hold fixed the complexity of our brains, and you think about all the interactions, all the input that children receive, all that is still insufficient to explain the acquisition of language. And therefore that we need to postulate not just innate capacities, but actually the presence of innate principles. That's, I think, what used to be known as the poverty of the stimulus argument. And I would like to know what you think the status of that argument is. And the other thing is something very short. Cedric, you talked about patient learners, and I just wanted to know, children are patient learners? It's an honest question. It's an honest question because it may be that, yeah.
Yeah. I guess both questions are for me.
Well, I can answer, but
Sure.
you start.
Why don't you?
No. Well, just I'm making a comment. I suppose that you are linking with the topic of Gold theorem, that given a sequence of symbols, and you don't know, just you receive sequences of symbols for which you know this is positive, this is negative. There is a theorem that says, okay, you cannot learn it unless you impose some biases, okay? And perhaps my message would be, conceptually it's a very powerful argument, but perhaps those biases that we thought that had to be encoded in our genetics are perhaps a consequence of limitations of our brain that we haven't understood well. And as you unfold it, as I have been showing, perhaps I tell you, hey, the game or the setting of Gold's theorem is poor because there is more going on once you add a brain there with, and you exploit all this inference that you can make just from, okay, this brain has to put heads optimally somewhere, okay, according to what? In short sequences or long sequences, okay? But moderator is calling me, okay? But now, Cedric, this is your...
Okay. Regarding poverty of stimulus argument, so the idea that basically there are many things that we know for which we have too little evidence to draw from. I think that, at least in part, right, the work on these large language models are showing that, in fact, in some respects, we may have underestimated the amount and quality of evidence that we get. That doesn't solve everything. So there are still instances where I think we don't really know what kind of evidence children use in order to draw the right inferences. But I think that this work is useful in showing basically that we may have underestimated the quality of the evidence that we get, the amount that we get. Regarding patient learners, I think we indeed are remarkably patient, comparatively speaking. So I think it's of course not the case that we are saints at any point in time, but we are remarkably resilient to failure in situations of exploring uncertainty at a particular age, right? So we find and I think this is very clear to anyone that has interacted with children. Children will repeat some of the same things until they get it right on the basis of what they intend to begin with. That is, they are willing to try and fail, as it were, up to the point where, not from the perspective of adults, but from the perspective of children, they're remarkably internally driven by intrinsic rewards. That is a very special aspect of our biology that we know is it has a brain basis, that is, connections between certain motor areas and reward areas of the brains are extremely enlarged already in very young children. In fact, when they are not so enlarged, you get neurodivergent phenotypes, all right? But I think we should indeed come to appreciate the fact that for a certain period of time in childhood, we learn very differently from adults, right? And that these traits, whatever they end up being when we articulate them in detail, are extremely useful in helping us constructing a language. That is, they allow us not to require the implausible biological requirements from the linguistic literature. Right?
Can I add something?
Thank you. I have a question about you had the scaffolding and you had the Eiffel Towers construction, and I'm a theoretical linguist too. So I used to use that image too, but I no longer believe it because I started looking at what you highlighted too, the importance of social interaction in child language learning. And at the edges of a proper sentence, there is a lot of little things like at the end, you're like, huh, or a, or sí or no, like requests for confirmation. Or at the beginning, you have particles like así, and then you keep going. And these things have been totally ignored in the proper treatment of grammar because they were not considered to be part of grammar, but they have a logic that I have convinced myself is part of this language faculty. And children, they start with the nouns and the verbs, so at the bottom, and with this stuff at the top, this interactional stuff. So now the way I think of the scaffolding is you grow inwards. So you start at the two edges and then you make it more complex. So I'm wondering, and just a little example, we are special as humans because the ability to interact with our offsprings, we are special because we're amongst the mammals that are the only ones that can have eye contact while nursing. We can make eye contact with the baby while we're nursing, like a cow can't do that. And that is one of the bases for this kind of interaction, turn-taking, and that makes us biologically special too, compared to other species. So I was wondering whether you thought about the importance of the language of social interaction, not just the fact that we interact, but the aspects of language that
I think it's crucial. So I think it's crucial that this interaction happens, in fact, to precisely stimulate those predispositions that children have. So the communicative interchange is very important in shaping the time course of language acquisition. But I would disagree on one point that I think shows you are a theoretical linguist, no offense, when you were saying at the bottom and the top, and what children do. I think one thing that's to bear in mind is that children do lots of things without saying them. That is, they know far more than what they reveal when they start speaking, right? And I think we should at least be open to the possibility that the things that they externalize by speaking or signing or whatever modality they end up using is a small fraction of things they have already put in their cognition. And figuring this out will be particularly difficult for linguists, because linguists feel, as it were, naked in the absence of sentences that are being externalized. They don't know what to analyze. But the neuroscientists might help us explain the richness that we don't see in the output of children.
I agree with that, except there's also the aspect, the typological aspect, that when you look at what is more or less universal across languages and what varies the most, is that, again, it's at the edges, the theoretical edges, that you have less variation. All languages, in my experience, I've looked at, many languages from different families, have these things that ask for confirmation and the vocatives and what's at the edges. And all languages have nouns and verbs. So that's where we have less variation. Whereas what's in the center, like not all languages have tense, like what's in the classic genitive tradition, the core of the sentence, right? Languages differ massively on that domain. So that fits with the fact that there is something that is more basic at the outset, and I totally agree that kids know more.
Excuse me, try to be very quick because we are behind schedule.
Your idea of this mathematical truth is very challenging and nice, but do you need it? So, because when you talk about biological determinism, in fact, we are talking about physics and chemistry, and we are talking about mathematics also there. Why do you need this third dimension? Is it not within it? Within the biology itself?
Quick answer,
Okay, later with a beer or a coffee. I'm not sure if I got completely your point. So we are saying, okay, if change the domain, replace language by chemistry and physics, then you also have material systems that obey some mathematical principles or models in a way. Yeah, you would say that there is no dissociation, or in this case, you would say that the dissociation that you seem to have been presenting wouldn't be here, because it's the matter and the mathematical reality altogether. I mean, are you, let's say, suggesting that I'm being dualistic, while in chemistry or physics you wouldn't? I'm not sure if I'm getting...
Is that this dimension, it is already within it, within the system, within biology. So biology, you can explain it also with mathematics. You don't need another dimension, which is very challenging. But I mean, why do you consider that it is a different dimension than biology, which is chemistry and physics?
Because then you can, this is a reality that then can be implemented in distinct ways. So maybe you have a species that, okay, the individuals don't interact in a social way, in a rich social way, but then, okay, in order to evolve communication, it has to be of some complexity or solve through communication certain tasks. It has to be done biologically, okay? But then in other species who are interacting more, you have vocal flexibility, capacity to imitate, as in, for instance, dolphins or certain birds, maybe, okay, it can be a cultural mechanism. So that's my kind of argument when I say mathematical, okay? So I would say as a complement to the apparently opposite views. And I said, okay, perhaps there's something unifying. So it's another dimension, but I would say it's a unifying thing, okay? Then, depending on the domain, the context, maybe you have to go for a biological path or a cultural path. That was my point. Is it clear?
No.
Okay.
A last very quick question, Luis, if you can be...
Yeah, I'll be very short. So one thing that I have found, I found both of these very interesting presentations, but one thing that I find missing often in these discussions is a consideration of what language is used to do. And so maybe to put the question specifically to you, do you think your measures of complexity or the way you approach that would look different if you thought about, well, some of the signal, for example, is used to coordinate on the things we are looking at and talking about in the world. Other part of the signal is used for categorization. And these are, I think, conceptually different things. So how does that fit in the picture? And, you know, if one looked at the, maybe this could also be for Cedric, at the skills of animals in the way they interact or their categorization skills to the extent that we can look at them, would we learn things?
Short answers as well.
Well, very simple one. You are pointing to complexities that for me are difficult to catch, integrate into, let's say, strong mathematical arguments from my perspective. So, and I have to simplify and reduce.
Cedric?
Or give me a lot of money. And many PhD students.
Short answer. I think, yeah, see, we've come to use language for so many different things. I mean, it's very hard to, in fact, imagine society as it is now. If we remove language, how would we function, right? But I think at bottom, it is a system for sharing information among, you know, conspecifics, right? And that I take to be a fundamental use. And then the others would be more derivative, but I don't know if that's fair or not.
Thank you very much. Thank you, Cedric. Thank you, Ramon. And thank you, Jama, for organizing this session. Thank you, all of you.